Hello everyone. In last class, we were discussing about reduction reaction involving in aldehydes and ketone. That is reduction. First one we already studied, that is a reduction to alcohols. Right? We already studied about reduction involved in aldehydes and ketones. In that, reduction to alcohols. Primary aldehydes always give rise to primary alcohols, and ketones always gives secondary alcohols, that you are knowing. In reduction reaction, second one is reduction to hydrocarbons. Second one, reduction to hydrocarbons. Okay. In reduction to hydrocarbons, there are two important reactions are there. First reaction is Clemmensen reduction, and second reaction is Wolff-Kishner reduction. Both the reactions are very, very important. Let us see first reaction, that is, first one is Clemmensen reduction or Clemmensen reaction. Clemmensen reduction or Clemmensen reaction, or Wolff-Kishner reduction or reaction. What is Clemmensen reaction? Aldehydes or ketones, aldehydes or ketones containing or having carbonyl group reduced to hydrocarbon. That is, carbonyl group is reduced to CH2 group here, reduced to hydrocarbon on reaction with zinc amalgam and hydrochloric acid. This is very, very important. That is, aldehydes or ketones having carbonyl group reduced to hydrocarbon, that is CH2 group, on reaction with the zinc amalgam and HCl. Let us study by taking one example. Ketone having C double bond O group, carbonyl group, on reaction with zinc amalgam ZnHg and hydrochloric acid. This carbonyl group will reduce to CH2 group. That's all. Okay. Carbonyl group will reduces to CH2 group on reaction with zinc amalgam and HCl. Byproduct is water. And this is about Clemmensen reaction. Important reaction. Just to see carbonyl group, that carbonyl group will reduces to what? Reduces to CH2 group, that is a hydrocarbon. The resulted compound containing only hydrogen and carbon atoms. Right? This is about Clemmensen reduction or Clemmensen reaction. Whatever the reaction is, whatever the reactant is, just to see this reagent. If there is zinc amalgam and HCl, just reduce C double bond O to CH2. That's all. Okay. Next, one more reaction here is Wolff-Kishner reduction or Wolff-Kishner reduction or reaction. B. Wolff-Kishner reaction or Wolff-Kishner reduction. What is Wolff-Kishner reduction or Wolff-Kishner reaction? Both Clemmensen and Wolff-Kishner reaction almost same except the reagent. That's all. Okay. Here aldehydes or ketones. Aldehydes or ketones containing carbonyl group reduced to CH2 group. Okay, reduced to CH2 group, that is a hydrocarbon group. Reduced to CH2 group, that is a hydrocarbon. Okay, reduced to CH2 group on reaction with what? Hydrazine followed by the reaction with dilute alkali and ethylene glycol. Here ethylene glycol acts as a solvent. Okay, say high boiling solvent, there is a ethylene glycol is used here. That is dilute alkali is either sodium hydroxide or potassium hydroxide. On heating will give corresponding hydrocarbon. That is the reaction C double bond O, that is ketone, on reaction with hydrazine NH2 and NH2. Right? This reaction we already studied. What is this reaction? That is reaction with substituted or derivatives of ammonia. Right? That is NH2Z type reaction. Clear? The formation of hydrazine to hydrazone. Now it will give C double bond and NH2 as intermediate. Here remol of water takes place, and which on reaction with alkali, right, potassium hydroxide or sodium hydroxide and ethylene glycol on heating gives, as usual, that is a CH2. The reaction is C double bond O will reduce this to hydrocarbon, that is a CH2 with the byproduct N2, nitrogen gas. Okay, this is about Wolff-Kishner reduction. The difference between Wolff-Kishner reduction and Clemmensen reduction is only the reagents. Here in Wolff-Kishner reduction, you can write directly the product like ketone, NH2, that hydrazine, and KOH, ethylene glycol, product is that. Hope it is clear for you. Sometimes they will give like this. Okay. And NH2 NH2 KOH, first reagent, second is a KOH and ethylene glycol, and heating, what is the product. Okay, just see here it is hydrogen and ethylene glycol, potassium hydroxide is there, and C double bond will reduces to CH2, that's all, and they'll ask name the reaction. This because of the presence of hydrogen and ethylene glycol and potassium hydroxide, this reaction is a Wolff-Kishner reduction. The products are same in Wolff-Kishner and Clemmensen reaction, that's all. The reagents are different. Okay, hope it is clear for you. Next is, third one is oxidation reaction. It is oxidation involved in aldehydes and ketones. As I have mentioned in previous classes, hydrocarbons will oxidize to give alcohols. Alcohols on oxidation will give aldehydes or ketones, and aldehydes and ketones on oxidation will give carboxylic acids, remember, or carboxylic acid derivatives. Okay, like esters, anhydrides, acid halides, etc. Okay, first basic is hydrocarbons or halides, alkyl halides or simple hydrocarbons, which on oxidation will get alcohol, which on oxidation or simple any basic alcohol, from alcohol will get aldehyde or ketone, and from aldehydes or ketone we will get carboxylic acids, remember this. Okay, now oxidation reaction involved in aldehydes and ketones. So what you should get? Oxidation of aldehydes and ketones, obviously we must get carboxylic acids, right? Why carboxylic acid we have to get? That end product of oxidation is a carboxylic acid, right? On reduction we should get what? Alcohols. Clear? That is third one, that is oxidation reaction involved in aldehydes and ketones, right? Aldehydes easily oxidize to carboxylic acids in presence of some mild oxidizing agents like potassium hydroxide, potassium permanganate, or nitric acid, etc. Or even with some mild oxidizing agents like Tollens reagent or Fellings reagents are sufficient to oxidize aldehydes, but not ketones. Aldehydes easily oxidizes to corresponding carboxylic acids. That is third reaction. It is RCHO on oxidation will give RCOOH. That is, in oxidizing agents like nitric acid or potassium permanganate or potassium dichromate, these are sufficient to oxidize. These are good oxidizing agent. Of course, potassium dichromate and potassium permanganates are very good oxidizing agents and are sufficient to oxidize aldehydes and aldehydes. But if we see ketones, these ketones will not undergo oxidation in presence of mild oxidizing agent. It requires some strong oxidizing agent and elevated temperature, and oxidation involved in ketone is like carbon-carbon bond cleavage takes place and results in the formation of carboxylic acids of carboxylic acid having lesser number of carbon atoms. This is about oxidation of aldehydes and ketones. Aldehydes will easily undergo oxidation in presence of oxidizing agents like carboxylic acids, oxidizing agents like HNO3, K2Cl2, O7, and that is potassium dichromate and potassium permanganate. But it requires, ketone requires elevated temperature and certain condition or strong condition or strong oxidizing agent to oxidize from ketones to carboxylic acid. For example, RCH2, C double bond O, CH2, R dash is a ketone which on oxidation, as I said, ketone on oxidation will give corresponding carboxylic acid with cleavage of a bond. Here, if I consider this as first carbon, second carbon and third carbon, okay, and here C1-C2 bond cleavage results in the formation of product like RCOOH plus R. If we cleave this bond, then we will get RCOOH plus R dash CH2COOH. It results in the formation of products, that is carboxylic acids, with lesser number of a carbon atom. That's all. And if C2 and C3 bond breaks, then it results in the formation of two more products that are CH2 COOH plus R dash COOH. If this bond breaks, then R dash COOH and RCH2 COOH. Two products are possible. Here breakage of C1 and C2 bond, here C2 and C3 bond breaking. Right? Next, as I said, oxidation of aldehyde. Aldehyde will undergo oxidation even in presence of milder oxidizing agent. In that, there are two main tests are there. In practicals, you will be having for Viva, that is test for aldehydes and ketones. In that, here we are going to discuss test for aldehyde, that is tolerance test. Tolerance test. Okay, it's nothing but oxidation reaction. Oxidation of aldehydes to carboxylic acid or carboxylate ion. That's all. And this is one of the tests to identify aldehyde group present in a in an organic compound. Am I clear? That is, if they give one organic compound, you are doing in practicals, you did salt analysis, right? Like that, you will get organic compound. Now it is not there. Earlier it was there in practicals. So if they give like salt, if they give some organic compound, you have to identify the functional group present in that compound. To identify functional group present in that compound, we have several tests. In that, tolerance test is one of the important tests to identify aldehyde group. And also tolerance reagent test or tolerance reaction is one of the example for oxidation reaction. That is, aldehyde will oxidize to carboxylic acid. In the sense, aldehyde will oxidize to carboxylate ion. Okay, that carboxylate ion, which on hydrolysis will give, or which on acid hydrolysis will give carboxylic acid. That's all. Okay, this is one of the example for oxidation reaction, as well as tolerance test is example for identification of aldehydes. Now, what is tolerance reagent? Before going to discuss about tolerance test, we must know what is tolerance reagent. Tolerance reagent is nothing but a ammonical silver nitrate solution. Ammonical silver nitrate solution is called tolerance reagent. Now, aldehydes on warming in presence of ammonical silver nitrate solution, if we take aldehyde or organic compound in a test tube, and if you warm aldehyde with the ammonical silver nitrate solution, okay, if you warm, then it results in the formation of silver mirror. Okay, results in the formation of a silver mirror. Along the sides of the test tube, you can observe the formation of a silver mirror. Beautiful reaction it is. Okay, silver mirror. This silver mirror formation takes place because of the formation of silver metal. Okay, after reaction with aldehyde and ammonical silver nitrate solution, this results in the formation of a silver metal. So we will get a silver metal along with the carboxylate ion, any carboxylate ion. Due to the formation of silver metal, we'll observe silver mirror. This formation of silver mirror indicates the presence of aldehyde group in an organic compound. Remember, okay? Clear it is. The reaction is RCHO aldehyde, RCHO aldehyde on reaction with AgNH3 twice, I'll write plus, ammonical silver nitrate plus, and NO3 minus. Okay, ammonical silver nitrate solution, and textbook this equation is given, so that I'll write the same AgNH3 twice, and in presence of base, it results in the formation of, as I said, RCOO minus plus silver metal and water. Sorry, and ammonia. Okay, results in the formation of ammonia. That is, and one more molecule of water. Yes, one more is water, and balance the equation. 2 molecules of this and 3 molecules 4 molecules ammonia and 2 molecules of water. This is about tolerance reagent test, one of the important test to identify aldehyde group present in an organic compound. Okay. Next is Fleming's test. Fleming test also one of the important tests to identify organic aldehyde group present in an compound, that is, just we'll see the reagents of Fleming solution. So second test, first is tolerance reagent test, second one is Fleming test. This Fleming solution, that is Fleming test, here we will use Fleming solution, and Fleming solution is nothing but it comprises of two solution. Okay, it is mixture of two solution, that is Fleming solution A, okay, Fleming solution A and Fleming solution B. Is mixture of Fleming solution A and Fleming solution B. Now what is Fleming solution A? Fleming solution A is nothing but aqueous copper sulfate solution is called Fleming solution A, and Fleming solution B is nothing but sodium, potassium tartarate, that is double salt of tartaric acid. Okay, double salt of tartaric acid is called sodium potassium tartarate or Rochelle salt. Okay, this is about Fleming solution A and Fleming solution B. Okay, Rochelle salt or sodium potassium tartarate. Structure of Rochelle salt is double bond O and O minus K plus or O minus Na plus. Here it is O minus Na plus. So O minus. Okay. This is double salt of tartaric acid is called Fleming solution B or Rochelle salt, and Fleming test is aldehydes on reaction with the Fleming solution, that is Fleming solution A and Fleming solution B mixture. Fleming solution A, it results in the formation of reddish brown precipitate. Okay, aldehydes on reaction with the Fleming solution, which results in the formation of a reddish brown precipitate. That formation of reddish brown precipitate indicates the presence of aldehyde group in an organic compound. Let us discuss its mechanism or reaction in the next class.